Hi-oh, here we are again. This time we're going to talk about the monkey and hunter. Well, once upon a time, a hunter was walking through the woods and saw a monkey hanging from a tree. He wanted to shoot that monkey. Well, but he knew the monkey would be scared by the noise of his rifle and let fall as soon as the trigger was pulled. So where should the hunter aim? Below the monkey? At the monkey? Above the monkey? By the way, I want to thank Mrs. Janice Lonroth for putting together this part of the PowerPoint. I think she did a great job. Well, it turns out you would shoot at the monkey. Because remember, both the bullet will start falling and the monkey will fall at the same rate. We have this path here called the narang, which is no air resistance and no gravity. If there was no gravity, no air resistance, the bullet would keep going on forever and the monkey would surely be missed. But remember, that bullet is going to fall away from that narang. And we've done the calculations, d equals 1/2 gt squared. In 1 second, it will fall 5 meters. So away from that narang. In 2 seconds, it will have fallen a total of 20. But at the same time that it was falling, it was moving horizontally. And so 20 meters from that narang. 3 seconds, 45, 4 seconds, 80, and so on down the line. Both the bullet and the monkey will fall at the same rate. So let's say this is 4 seconds up here. We know that the monkey in 4 seconds would fall 80 meters. Well, if the bullet made it to this point, we know it would also fall 80 meters. They both fall 80 meters from this point. So here we go. Let's do some calculations this time. So we actually did this in class. We shot the monkey. Suppose the launcher down here was at an angle of 50 degrees from the ground. The muzzle velocity is 80 degrees, or I'm sorry, 80 meters per second. What vertical distance would the bullet have fallen after 2 seconds? Well, it's that same. If you go back, d equals 1/2 gt squared. And the distance it will have fallen, 1/2. G is -10. We're just going to throw 10 in there. We know it's downward. The time is 2 seconds. Don't forget to square that. And you get, of course, 20 meters. Remember, anytime something is falling and you need to know a distance, this is the formula usually to fall back on. Well, here's a silly question because it's going to set us up for the rest of this problem. How many seconds is the bullet in the air before striking the monkey? Well, remember, here's our picture, and it is 4 seconds. So what's the range? How far, remember, the distance horizontally is the range. How far horizontally does that bullet have to move? Or, I'm sorry, does it go? Well, to do this, there's a couple of different ways. I'm going to show you the one I want you to use right now. In order to do this, we need to re-look back at some things said before. It's an angle of 50 degrees and the muzzle velocity of 80. We essentially have something that looks like this. The muzzle of velocity of 80 meters per second, and it's 50 degrees from the ground. looks like a right triangle to me with vectors. Could we solve for this side of our triangle? If we do, we would have the velocity of that horizontal distance, right? The velocity that bullet would move horizontally, so we could figure out how far it went. Well, let's take a look. We know that we're dealing with the hypotenuse and an adjacent side, so it's the cosine of the angle equals the adjacent side over the hypotenuse. The cosine, we know the angle is 50, equals the adjacent side, some unknown, divided by the hypotenuse, which is 80. And when you solve that, what do you get? 51.4 meters per second. In other words, this bullet in the horizontal direction is 51.4 meters per second. That's how fast it's going. How many seconds was it moving for? 4. So it's basically 4 seconds times the 51.4 meters per second, and we are left with 205.7 meters. There you go. Lastly, let's talk about that narrowing path. Right along here. We know it's traveling for 4 seconds. How far? Well, this is at 50 degrees, right? And we know it's traveling a time of 4 seconds. We know it's traveling a velocity of 80 meters per second. Well, we know the velocity is distance over time. Therefore, distance is velocity times time. The velocity is 80. The time is 4. And therefore that comes out to 320 meters. There you go.